Okay. So what do I know by just looking at it? The zeros are negative 2, 0, and how do you know? So I have to equal this to 0. So x plus 2 equal to 0 makes negative 2. And x minus 4 equal to 0 makes a 4. So I know I have zeros at negative 2, 0, and 1, 2, 3, 4, 0. Now what? Somebody new. What's the next step? Let's hear it, Liz. How do you know? Because right in between them, right, you could just count. There's another way to do that by putting in negative b over 2a. But I don't even need to do negative b over 2a. That's that's how you find the axis of symmetry. But why would I need a silly formula when I could just count? They all work like that. You can always find the middle, right? This. You can always find the middle by just counting, right? Okay. Can I find the vertex now? How can I find the vertex? I already know what x is, so in order to find y, I just substitute in, right? I know that the vertex lies somewhere on that line that I just made, right? The axis of symmetry. So if I substitute 1 back in, if I substitute 1 back in, I'm going to get negative 9. So my vertex is 1, negative 9. Does that make sense? By just looking at it? There's another piece of information I have that I didn't put up here. I know what the Y-intercept is even before I started graphing. Uh-oh. Fidel, I didn't just hear you say that, did I? Okay. So my Y-intercept all I have to do is multiply 2 and negative 4, and I get negative 8. Okay. Taylor, you want to explain a different way that you found the vertex? Taylor went down over 3 and down 9. Why in the world would she do that? She said it's 3 over here, so I'm going to go over 3 and down 1, 2, 3, 4, 5, 6, 7, 8, 9. How did she know that? Taylor, how did you figure that out? She did our magic numbers in reverse. She said, I know that if I had my vertex, if I went over 1, I'd go up 1. And if I went over 2, I'd go up, how much? So it's over 1, up 1, and then if I square 2, I get 4, and if I square 3, I get 9. So therefore, right, I could go in the reverse and go over 3 and square 3 and get 9. That was pretty smart, right? And if they were 4 apart, how far down would the be 16? And if they were 5 apart, how far would you have to go down? 25. Good. Okay. So that's that. You guys are doing a fantastic job. It's going to get more complicated. What's this one going to look like? What's this one going to look like? Just by looking at it, guys. You don't need to do it.
Upside down. Oh wait, there's two. Yeah, there's two. Is it? Oh really?
This doesn't make any sense to me right now. Hold on. Somebody texted me about my kid. Sorry. Carpool. Okay. So how does this one look different? Show me with your hands. It's going to go down. What makes it go down, Fidel? The negative sign out in front. Okay. Where's the Y-intercept? It is -7, right? Because -1 times -7 times -1 is going to be (0, -7). Let's see if that, we got to make sense of it. Right, Amadeus? Let's make sense of it. If this is -0, -7, and my zeros are at 1 and 7, is that going to make sense? 1, 2, 3, 4. 1, 2, 3, 4, 5, 6, 7, 8. That's 8. Hey, I have a question for you. Let's tailor it. Where's the vertex going to be?
In the middle, right there. So,
If it's, I love it. So if this is 3 away, where's the vertex going to be? I know it's going to be here. How far up is it going to be? It's 3 away. 9. Right? If it's 3 away, it's going to be 9? All right. Does that make sense? Okay. Let's keep going. What more fun things do we have? What about this one? I'm going to pause it. Okay. Let's see here. Give me a second here. All right, feels like I haven't been teaching in like 10 years. All right. This is actually a perfect square trinomial. Because half of 4, let's do this. I think I'll put it here. Guys, remember this? If this is an x squared, and I have 4 x's, and I split them in half, wouldn't I have 2 x's on each side? Right? So what would I have to add to complete the square? What would go inside the box? Remember that? 4 1s would complete the square. So what you do is you cut the 4 in half and you square it. So this, I should be able to look at it. Whenever I see an even one right here, right, I should immediately ask myself, is this a perfect square trinomial? So half of 4 is 2, and 2 squared is 4. So this is a perfect square trinomial. So you're going to go to the left 2. That is your vertex. That is your axis of symmetry. And so all you need is over 1, up 1, over 2, up 1, 2, 3, 4, which makes sense because this is 4. All right, I think we need to go harder. I'm going to pause it and give you guys some time for this, because I think there's going to be different strategies. Okay, like I said, I'm really happy to say that almost everybody did it the most efficient way possible. So I'll do that super, super quick, and then we'll go into the inefficient ways that can be done. Because it's good to see it in different ways. The easiest way to solve this, or to factor it, would be it's got a greatest common factor. So I already know my zeros are 0, 0, and, 0, 0, and negative 4, 0. That's the easiest way to do it, right? Another way we could have done it, let me duplicate this page. This is how most of 5th period did it. Almost everybody in 5th period did this. Which also works, right? Then another person did it this way. There's a reason. Okay, then another person did this. They set it equal to 0. And they added 4 to both sides to complete the square, right? Then you could square root both sides and get plus or minus 2 equals x plus 2. Then, but on some of these, you're gonna have, the reason I'm showing you this right now, there's a big reason for it. So now I've got x plus 2 equals positive 2, and x plus 2 equals negative 2. If I subtract the 2, I get 0, and, which is exactly what I have here, right? One more, Amadeus, one more. Or, you ready to be mind blown? Okay. I'll do it graphically. If I add 4 to this side, I have an equal sign, right? So what does that do to this right side? If it's like a scale. I just tipped my scale by 4. We want to call it pounds. 4 pounds? Right? How could I untip it? But I don't want to add 4 to the other side. But now I'm tipped. My scale's tipped, so I added 4. I could also subtract 4. Correct? What did I just add to that side? I added nothing. I added 0. Check this out. Now it's a perfect square, right, with a negative 4. Right? Do you guys remember this? What is, now it's transformational. Nope, don't need to. This is in vertex form, guys. This is in vertex form, so what's my vertex? Negative 2, negative 4. Is that what we had here? We didn't graph it. So but negative 4, 0, and negative 1, 2, 3, 4. 1, 2, 3, 4. Axis of symmetry is at 2, right? So you go negative 2 down 1, 2, 3, 4. Negative 2, negative 4. Isn't that what I said the vertex was going to be? Negative 2, negative 4? Somebody figured out that you could complete the square, but then I showed them this, that it's the same thing. Okay, let's move on. Can you guys do this one? Okay, so let's try this strategy. I already know the Y-intercept. I'm going to wait for it to get quiet. That's much better. Okay, so I already know the Y-intercept. It's right here. 0, 4. All right, I've got an even number there. I like even numbers in that spot. Why? Because I can split it and square it to make a perfect square. So I have y equals x squared. Let's do this. Y equals x squared plus 6x. I can turn this into a perfect square by splitting the 6 in half and squaring it, right? So I would add 9. But I still have that 4 there. Hold on. So I have 9. Most of the time you guys would add 9 to both sides, right? But I want to graph this thing. So when I add 9, I just tip my scale. So how could I untip it? Did I add 0 now? Everybody okay with that? I added 9 and I subtracted 9 so that I could make a perfect square trinomial. So now I just have that. So now where's my vertex? Negative 3. Whoops. Negative 3. Sorry. Negative 9 and positive 4 is negative 5. Thank you, Amadeus. This right here is this, and negative 9 and positive 4 make negative 5. Make sense now? Do you see it? I added 9 and I subtracted 9, so that's adding 0. I used the 9 to make a perfect square trinomial. And then all that's left over is what's not in blue, which is my 4 that I already had, but I didn't need because the 4 wasn't made it so it wasn't factorable. So I just like scooted it over. We scooched it. What property says so I can scooch something? What property tells me I can scooch? No, associating is associating with something. Commutative property tells me I can move, I can commute, right? I can move it. Okay, so I'm losing some of you. So I have a positive 4 and I have a negative 9. That's what's left over. I added the negative 9, right? And I had the 4 left over. So I put those together and I get negative 5. So now it's in vertex form. Negative 3, negative 5. Does that make sense? I know what a parabola shape should look like, right? Over 1, up 1. Over 2, up 1, 2, 3, 4. over 3 up 9. 1, 2, 3, 4, 5, 6, 7, 8. Uh-oh. 1, 2, 3, 4. What did we do wrong? I did something wrong, right? Because I should have landed on that point. I see it. Do you guys see what I did wrong? -3, -5. I didn't go down 5. -3. 1, 2, 3, 4, 5. Over 1, up 1. Over 2, 1, 2, 3, 4. You guys are being too loud for me. 1, 2, 3. 1, 2, 3, 4, 5, 6, 7, 8, 9. Bingo. Yep. You guys want to practice another one completing the square? Okay. Do that one. All right, so I'm going to do this one for you. So this, right here, this 2 is doing nothing for me, right? It's useless. It does give me, you're right, it's not useless. It does give me the Y-intercept, right? But it's not going to factor for me. So I'm going to scooch it. So I have Y equals x squared plus 6x. And I'm going to scooch that 2 over because I don't need it. So what can I add in order to have a perfect square right here? If I cut 6 in half, I get 3. So 3 squared is, so I'm going to add 9 and I'm going to subtract 9 so that I'm adding nothing. My scale is still even. So now I have Y equals x plus 3 squared minus 7. So my vertex is -3, -7. I have one more thing to show you, and then we're going to pack it up. Okay? No, you're not going to have any homework. So pencils down. Cap your pens, please. You don't put that away. All right. This is the last thing I want to show you. There's one other thing I wanted to show you, but this is... So I had 2 other things, but I'm only going to show you one. So you guys already know how to do this. You've already been transposing. That's another way to find an inverse of something, correct? We transpose x and y, and we solve for y. So on this one, my next step would be add 8 to both sides. Then my next step would be divide everybody by 4. Then I get y equals 1/4 x plus 2. That's what you guys have already been doing, right? Transposing x and y. So what do I do when I have something like this? Let's do this. So, let's get rid of all this stuff. One more. Oops. Let's grab it all. All right, so same thing. I want to transpose x and y, but now I want to solve for y. Correct? That's how I'm going to get the inverse. Does anybody see what I could do? What's the inverse? What I really want to get rid of, ultimately, is I want to get rid of that squared. How do you get rid of something? You do the inverse. Get that, right? We're trying to find the inverse equation, so we're going to do the inverse to y, and we're going to square root it. But I can't just square root it, right? You know what I did wrong here? Look what I missed. I missed the y. Okay. So how would I square root it? What do I need to square root something?
Oh, it's a perfect square.
It needs to be a perfect square. This 8's not going to make it a perfect square. So I need to make it a 9. So I have x equals y squared plus 6y plus 9 plus 8 minus 9, right? Couldn't I, instead of minusing 9, since I have x over here and I want to solve for y, couldn't I just put a 9 on this side instead? Wouldn't that make it easier? Do you see that sometimes you're going to want to add a 0 pair and sometimes you're just going to want to add the same thing to both sides? Because half of 6 is 3 and 3 squared is 9. Shouldn't I also move that 8 over 2? I shouldn't? I'm trying to solve for y. Let's back it up. Shouldn't I have started here? Does this look more familiar to you? Does that make us feel a little bit better? Now what do I want to add to both sides? And now I have, you guys, I'm going to get irritated if you pack up right now. Just give me a second, I'm almost there. Now what? How do I solve for y? What's the inverse function of a quadratic function? What's the inverse function of a quadratic function? It's a radical. Have a great day, guys. See you tomorrow.